think this should work. Okay, let me try and share it and see if it's working for you all. Ideally, it should. You should be able to see my screen. Okay, are you able to see this stream in the YouTube link? And also, are you able to hear me? I think you are, right? Because I can see my mic working all fine. Okay. Okay. Can you not hear me? Because I can see some people are saying you can't hear me. So I can. Can you hear me now? Okay, you can hear me. And can you also see the stream on the YouTube link now? For the people who are on YouTube. Because ideally you should be able to see it because I'm sharing my entire screen. Yeah, I don't think there should be any issues now. Okay, perfect. So then we are good to go. I'm also gonna hit record just in case anyone is not able to see this. Perfect, let's start. So we're not going to waste more time. We're going to get right ahead into the workshop. Let's also discuss some ground rules for the workshop really quickly. If you have any question, feel free to put it on the chat or to also nominate yourself to come up on the stage. And if you want to ask it live through voice, we are okay with that as well. The only bit is I'll keep oscillating between multiple screens because today it's only going to be me. Vittorio is not going to join me. So expect like a bit of 10 to 15 minutes if I'm in the session. I'm going to have to come back and see on the chat. That's the only thing. I think other than that, we're all good. So let's start. So today, the workshop is all about building physical AI agents with Cyberwave. How do you actually build something with real robotic hardware? And how do you take it and test it from real and from sim to real, right? Now, there are multiple things involved with the physical AI agent. So I'm just going to start sharing my screen. I hope the screen is visible. Can I get a quick yes on the chat? Only then I'll move to the other screen and start sharing other stuff. Perfect. Thank you, Akhilesh. I think you are a really big sport for me today. So let's move to the other screen where we are here, and let's quickly go back to the platform real quick. So what's a physical AI agent, right? We're not going to go into really basics, but just to understand what's the difference between a digital AI agent and a physical AI agent. In a physical AI agent, we plan to build something which interacts with the real world and also put something out in the real world. So in a very straightaway action item, for me, a physical AI agent is always going to be something which takes input from the real world, then think about it, and then also does an action which basically gives it back to the real world. Okay, this is also a very basic physical AI loop, which is a sensor, which is sense, think, and then act. Okay, now how do I take input from the real world using sensor? That can be a camera, a microphone. How do I think? Now there are multiple ways to think, right? I can use AI/ML. I can manually give actions to the agent to think, and then how do you act? And basically anything you put out again is an action. So if I'm putting out an alert outside via email, that's an action. If I put out something like a sound, if I put out a speech, again that's an action. So action is anything that that's an outcome of the thinking that we did on the basis of the input factors we took. Again, not going back into theoretical concepts or theory. So let's really start building a physical AI agent from scratch. You can also do this with me, just to make sure that you have all the things that you need to actually do this and perform this live. We're gonna go and use this particular repo that we have here. I've put it out in the Discord chat. I'm also putting it out there in the YouTube chat. So this is the repository that we're using today for the workshop. Every example, the first physical AI agent example we're going to use is also in this particular repository. Let's go back to the platform. Now, let's understand what we are planning to do or what we are planning to build today. Today, we are planning to build an agent which and mind you, I'm just going to repeat again the concept of it, which without being connected to any real physical hardware will be able to move around in simulation with our Python code. So let's just quickly understand again what are the basic fundamentals of this. So this is the platform that we're going to use, which is Cyberwave. If I create a new environment, and going back to the basics, what is an environment? So if for example today I have a can here, okay, this is my physical world. I have a can and I have a mobile phone over here. These are the physical assets that I have. Similarly, this is very similar to the physical robotic hardware that you have, like the SO101 robotic arm, the UGV beast, or the robot that you have, which when you connect to the remote robotics lab in Milan, you use, okay. These all are physical assets, which means the place where I am sitting at right now, or the place where you are at right now, is a physical environment. I want a virtual environment. Why do I want that? Because in order to run the entire agent, or in order to run and test the entire agent in simulation, I need some working and logic to make sure I do not fail in the real world, or do not deploy directly in the real world. It's just like digital AI, right? We do not deploy directly in prod. We split across multiple servers, maybe dev, staging, and then move to prod. Similarly, physical environment is our prod. So we move across in similar stages. So we started in simulation. So the first one for me is going to be here, which is new environment. Before I go there, I want to show you the catalog as well. So whatever and physical asset I have over here, a phone, a can, anything like that, whatever asset I have, I can have a digital twin or a virtual replica of it over here in the platform. But a digital twin is not just with respect to the identity or the physical looks. No, a virtual replica or a digital twin is actually made across 3 fidelity engines. The first one is the physical schema or the 3D schema, which means that this particular asset is going to be replicated in a 3D geometry on the platform. The second fidelity is actually the movement, which is how does the particular asset move, which is the kinematics of the asset. So in this particular sense, of course this doesn't move, but if I'm using a robotic hardware, what are the kinematic actions of that particular hardware which need to be exactly previewed in the virtual replica or the digital twin. I'm also going to keep checking the Discord chat just to make sure I'm audible. Okay, perfect. And the third fidelity is actually the real to the digital twin sync, which means whatever action I am performing on that particular real asset is also replicated across the digital twin. If that's okay, we can also view a lot of capabilities which are associated with every asset. For example, it can locomote, which means it can move. It can manipulate, which means it can perform actions while being fixed. So like manipulation, movement and locomotion, navigation, that's all. So let's start creating our first physical AI agent. Now what the agent is going to do, I'm going to create my first agent which is run by my voice. And I want that to be with the SO101 robotic arm. But of course, I'm not going to show you that with a real robotic arm because it takes a much detailed setup. So today I'm going to show that to you in simulation, and we're going to also see how to do it in live, like with the real robotic arms. So I can create environments with AI. I also have a lot of templates that I can use. But for now, I'm just going to show you for scratch. We're going to say SO101 test workshop. You can give it a description and then create an environment. So again, to come back here and to understand what is happening, this is my environment, which is a virtual replica of my physical environment. This is an environment agent. So I can use this AI agent to add digital twins and to add and create workflows as well. We use the Cyberwave MCP server for it. If I go to the workbench, I can create automation workflows from over here, and I can see my execution history. I can see the edge devices I have been connected to, the alerts, the events, and then all the logs. Now here, if I see, these are my primitives that I want to be able to understand. Someone asked me, I remember in one of the office hours, can we add other objects as well. So you can see you can add cube, wall, but also like more stuff, right? And you can also add waypoints, you can define an area, or all of this you can do just with an AI, just with a prompt. For today, I'm just going to create and add an SO101 digital twin. So this is my twin. If I go here, you can do a lot with it. You can accordingly manipulate it or like adjust it in a similar way. I can also move to live and see how do we set it up. But for today, I'm just going to move to simulate and actually see what I can do. So when I switch to simulate, I can see that there's already a keyboard controller assigned to the SO101 robotic arm. So let's also test this out. So if I'm pressing equals, it's moving. If I'm pressing slash, it's moving 6. Which means it's connected, right? It's working all fine. So I think this is perfect. This is good to go. But today, this is not exactly what we want to see. We want to see how do I control this robotic arm in simulation unanimously with not this controller, but with my code or with my voice, right? So how do we do that? Let's actually first I want to hear it from you. Do you have any ideas as to what all tools can we use to control the SO101 robotic arm without a keyboard controller, but something which helps us use our voice? So throw random terms at me, I'm going to be okay with it, right? So first question is going to be, how do I convert my voice into a prompt for the robot? I can see several people are typing, which is nice. Okay, I need answers. Yes, so what do we use? What do we use here to convert my voice into a detailed prompt? Yes, so Deepak, you are 99% right, because we are using speech to text, but I know you meant the same thing. Yes, speech to text, exactly. Perfect. Use some AI model which can do STTT for robot, and it should be able to act as controller to control the actions. Right. Nice. Whisper flow. That's a very good STT model. We are not using that today. I think we are using the Mistral Voxtral Mini because it was more efficient for our use case. But exactly, yes. So we are on the right track. So in order for the robot to hear us and then take actions according to what we are saying, we need a detailed stuff here, right? We just can't use one particular model, and there is a particular workflow involved here. So let's quickly go and understand this. So I'm just gonna open something else here which is actually going to help you after this as well. So there's a tutorial and there's an agent that we have already built, but just to show you that what is the architecture going to be like for this particular agent, I'm going to show this to you. So today we're going to build something where our laptop acts as a microphone, or basically takes my audio or my voice as an input. Then we can also use a USB webcam to also add vision to it. But when I feed in my voice as an audio, we feed it into an STT model, which is the Mistral Voxtral Mini, to convert it into text. Now this particular text that I got, I feed it into Claude Sonnet 4.5. You can also use another VLM or LLM model. By the way, VLM model is called a vision language model. It's an LLM, but also it takes images as an input. So it's not just very equivalent to an LLM. So here Claude Sonnet 4.5 acts as a multimodal planner, which can take different modalities as input. And the outcome it gives us is a JSON motion plan. Now the reason why it is very important for us to take this JSON motion plan is because the robot or the Cyberwave SDK we are using is not going to understand our natural language, right? What will that understand? We'll have to feed in exact motion actions. For example, move the joint to 1 to 30 degrees. But I'm not giving in inputs in this particular language. What I'm going to say is wave at the audience, or maybe try and make a circle, right? So what does Claude Sonnet 4.5 here do? It converts my natural language into a detailed JSON motion plan as per the joints for the robotic arm. And then the most important part here is we cannot just treat the outcome of this VLM planner as a trusted input for the robot. Why? Because it can hallucinate. The VLM can give wrong actions. It can cause the robotic hardware to go at an angle which might not be its desirable input. And again, it can lead to so many things, right? Because this is a physical AI agent. We need it to be responsible enough to not undergo an action which can harm the environment or harm the person or the controller. That's why we add another function here called the motion executor, which basically clamps and ramps. There are two functions. For ramping, what do we mean by that is that every particular joint here is set to a predefined angle limit, which means that joint 1 can only move from 5 to 75 degrees, and this is a random example. But what does that do? What that does is, even if this particular node here or the VLM will give me an outcome or an output which is not right, which is incorrect, or it hallucinated, still I have functions here which prevents the robot to do something which might not be the best action, right? So this is what we do here, and then we use the Cyberwave SDK to take the motion plan and control the robot with just one SDK use. And that's precisely it. So not going to go into more into this, but if you want to read more, I'm again going to put this link in the chat to make sure that you all can definitely read more. And now we're just going to go directly into the code. So now how will this work for you? If you are into this particular repository, all you have to do is clone it and basically go into this examples subfolder and the NLARM controller folder. Okay, now when you go into the NLARM controller folder, let's quickly understand what the code is first. There's the .env file. Please make sure that you do not leak these secrets, because after this demo I'm going to be removing them anyway, but still I will recommend not misusing them. Now here in the .env we are putting in 3 to 4 different types of inputs. So let me quickly take you through that. The first one is the Cyberwave platform inputs. What else? What do I need to use Cyberwave? I need the API key to make use of the SDK. I need the twin ID and the environment ID. Now where do I get this from? So I'm going to go back to the platform. This is my twin. I'm going to click on the 3 dots here, go to the Python SDK, and I can see the twin ID, I can see the environment ID. Okay. If I do not want to use this, I can also see them here. I can also copy the UUID directly from here. But this is always a very simple setup for me to just copy the twin ID and the environment UUID. Make sure that you actually set this up very clearly, because if there's any problem or error here, I won't be able to control and I won't be able to connect with the twin in the simulation engine. These are some predefined factors that you can use. Now, two quick things. We are using Anthropic because we're using the Claude Sonnet, some particular 4.5 model as a VLM. So we need an API key of Anthropic. So you can go, if you are using Claude already, you can just go to their dashboard and create one from there. And all of this is free, so you do not need to pay anything. And then for Mistral, you can also go and sign up on Mistral and create an API key there, because we're using Mistral Voxtral Mini STT to convert our speech into text. And then there is the last thing, which is CW mode. Now this is very important factor again here, because today we are going to try this in simulation, but maybe in the next time we're going to try it live. So you can change the CW mode from simulation to live whenever you are trying this with a real robotic arm, which is again going to be our next particular demo. Now if we quickly go here and understand the code real quick, it's very simple. We have a voice.py file over here. What does this do? This whole file is essentially to take your input and then use the Voxtral Mini model to convert it into speech and generate it there. So if you see, we have the def transcribe function. It uses the Voxtral Mini. It creates an output which is returned to text. And then we also have different functions to make sure there is no utterance. Okay. We're not going to do vision.py because we're not using that today. Then let's understand motion.py because this is the motion executor for the SO101 arm. What does that mean? That means that this is where I control what kind of motion plan will be generated for the SO101 arm, which means here I have already defined the joint limits. for every particular joint name. So there are 6 joints for the SO101. We have already set joint limits which for every particular joint. So like for example, the one joint, the minimum angle is going to be this and the maximum angle is going to be this. Okay. Similarly, we have also added some action types, which means what all actions can be performed on the SO101 arm, which means set joint, set pose, wait and home. This is equivalent to the SDK that we are using. Okay. Now here, this is the validation and clamping function that we have over here, which means it basically helps us avoid all the possible errors that can be produced by a VLM, or it basically helps us get around all the hallucinations. Okay, so this is the motion executor. What it helps us is, it helps us get a motion plan specific to the SO101 arm. But the actual thing here is this LLM motion planner, which means once our voice gets converted into text, Claude uses that natural language text into a validated motion plan, which is then given to the motion.py file, right? So if I go here, I've already added a system prompt which has every particular detail around the SO101 robotic arm. So make sure this example is only for the SO101 robotic arm, because we have specifically curated this for that. So all the joints, all the output format, all the rules, which is exactly the limit, the angle limit and stuff like that. Now in the motion.py file, I also wanted to show you something else, which is 1 second, joints.set. Yes. So I want to show you exactly how do we use the Cyberwave SDK here, right? So if I go back here and if I go here, you can see that it's a very simple quick start example of how do you use Cyberwave SDK. You just install Cyberwave with pip install Cyberwave, and then you create the robot twin, okay, which can be created from directly the platform itself as well. But more than that, how do you use the SDK? What are the different methods that you can use to control the joints? So a very important method that we're using today is robot.joints.set, which means the twin that we have instantiated, which is this twin in our case, if we particularly give the joint name and the angle, it will change the joint to that position. And this is exactly the method that we're using today. So you can see there are different type of joint control methods. You can use all of them. You can see which one do you use. But today, for here, we are using self.robot.joints.set, and then the joint name, the angle and the degrees. So what happens is, once my natural language gets to Claude generates a motion plan which comes to motion.py, and then here exactly with this the motion plan gets executed for every particular joint. And just to wrap this up, this is our main actuator or controller file, which is the nlarm controller.py. We instantiate all the credentials here, all the variables here, and then we basically just create a loop. We again keep adding voice, text, and we keep calling in the same functions. So the most important function for us today here is going to be this one, where I say I connect to Cyberwave and then I instantiate the Cyberwave the Cyberwave bracket, which means it instantiates the API key that I gave into .env, and then it uses cw.affect cw_mode. It's also an SDK, the Cyberwave Python SDK method, where we either call simulation or live. So this basically helps us decide if we are using a simulation or a live mode. And then I create or instantiate the robot object using the twin key, the twin UUID and the environment UUID. And then I call the motion executor robot function, which is the same function that we just saw today right now. So like this. And once that is done, it keeps calling in the loop. So this is exactly the code that we have today and that we are going to run today. But what if you are starting this for the first time? What all do you have to do? So for the first thing is, you have to go and go to the nlarm controller function. So right now I'm in examples. I'm going to go to nlarm controller. If I see I'm already here. The next thing that is very important for all of us is basically to install the requirements because we need certain things. So let's quickly show you this, and then let's also install Cyberwave. Okay, perfect. Now you can also export your Cyberwave API key here, or you can do it in .n, however you want. Like you can also export it in terminal and use and copy paste this here. And I'm just showing you this so that in case you don't want to put it into your .env. I hope that is all fine. I'm going to come back to Discord and see if there are any questions. Can I collaborate with multiple people on an environment? Yes, you can. You just have to share it. And the right way to use that is going to be share it. And then you can either control the visibility, and then you can add and control the access of different users and add their email address here and collaborate. I don't see any other questions. I'm going to keep moving, and now comes the main part, which is how do we like see this in action. So let's do this. Let's first see if this is working, right? So I'm just going to call in the main file, which is this one. Now it's saying connecting to Hyperwave homing, and then it says MQTT connection. So it created an MQTT connection. Now let's quickly understand what happened here. The mode is simulation, the planner is this, the twin is this, and this is the environment. Perfect. Okay. Now how do I set this up? So in my code, I have added a function where the laptop or the agent will only take my voice input once I press the space bar and I keep it. So I'm gonna give a particular command in voice. So let's try this. Wave at the audience. Okay, it didn't work. I don't think it did. Okay, so there is one quick thing that I forgot, which is I only added nlarm controller.py, but I also have to add voice because I've added a flag here which lets it understand that, oh, this is where I need to take the voice input, and before it was only taking a text input. So it should work now. Yes, let's try this. Wave at the audience, then take a small bow and say goodbye to the audience. So it's transcribing, which means it used the STT function. Okay, now I have the text, and now it's creating the motion plan. You see 1, 2, 3, 4, 5, 6, 7, 8. So it did 8 actions. But this is just how it looks here. Now we're going to see it in simulation. So I'm going to take this, do the same, give the same input, and then we're going to see it in simulation. Wave at the audience, then take a small bow and say goodbye to the audience. Okay, let's see. It waved. Now it should do a small bow. Perfect. And it should say goodbye. Okay, I think this was the goodbye. Now let's try something different. Try to make a circle with your hand. Okay, let's see if it does something. Yeah, so that is how the circle part worked out. But if you want to understand, right, I think the workflow is pretty clear to you now, that the natural language and the motion planning, and then how easy it is just to use the Cyberwave SDK method and control everything with just the SDK. That's pretty much it. Actually, I'm more than happy to take some inputs from your side as well. So what other commands should we ask to the platform? We have, okay, we have 7 more minutes before we hit a stop in this workshop, but I'm gonna, yes, so let's hit it on Discord. I'm back on Discord. You can also check YouTube. Which Python version? I think it's 3.13 or something, most probably. Okay, I'm gonna stop streaming for now, and I'm gonna keep asking, so taking more questions. So hit me with questions. How can we record the data from simulation for policy training? Amazing question. Perfect. I'm gonna go back online and I'm gonna show this to you. So if you are here, right, all you have to do is go to data. First, let me understand. So if you go to replay, yes, if I go to replay here, whatever recording I would have done with the actual robot, I would be able to see it here. And then if I go to data, I can go to recordings. I can find a recording for this one, and then I can trim it into episodes. Then I trim it into episodes. I create a data set with those particular episodes that I trim, and I then go to okay, once I have here, I can go to AI, and then I can go to start new training with that particular data set and a particular model. So for example, this is the template. I can use a particular data set here. I can use the model I want to train it on, and then I can start training. I can also do more advanced settings here. Now once I do that, then I can, and once the training is done, I can also deploy the trained model once the training is completed to that particular robot. I hope this is clear. Does the LLM model just guess the values for the various parameters, but providing a live preview of what the model is doing in the robotic arm on a simulation help in improving the accuracy of the action? So Nishit, I'll quickly help you understand what we are doing in this particular session, right? Yes, we are not using any sort of feedback back to the robot to help it learn from its actions. What we are doing to right now is just that the Claude Sonnet or the VLM, based on the prompt and the context of the robot, it is just trying to generate an action on the basis of the prompt that we are giving. But if we want to give the feedback of the actions of the robot as per every prompt, we can always use RL, and we can always use reinforcement learning, and of course, yes, it will help in improving the efficiency and the accuracy. But I haven't tried it with this particular agent, but for sure I think we can do it. And I can also see that we have Vittorio, so I'm just gonna ask you to come here. Okay, is there a way to set up local server and not use the compute credits? I think you can, but I think I'll also need to check with the team first to get back to you with the exact steps. But if I'm understanding it right, you are maybe referring to the on-prem version, and I think yes, you can do that. So is there a problem with my microphone setup? Because some people can say that they're able to hear me, but other people are saying they are not able to hear me. So is there a problem with my setup, or okay, it's crystal clear for some people. Okay. I just took a screenshot with all the questions to make sure we can get to them. Okay, I'm also gonna look at the YouTube link just to make sure we do not have any questions there. No questions, so I'm gonna keep here. Okay. We might have to, okay, if this is the problem, we should also understand what other platform we can use, because in my experience, Discord has been very helpful. But we let me see if we can use some other platform, or maybe for a smaller gathering we can use the voice channel, since there were not so many issues there. But I understand. Okay. Can we use Olama instead of Anthropic, because Anthropic key cost a bunch? Yes, absolutely. You can use Olama. You can use any other model. I use Claude because I wanted to try it out with Claude, but use other VLMs as well. We want to make sure that we can use open source. Zoom and Teams. Yes, I'm going to try that for the next time. The reason we prefer Discord is the community is here and it's easier to manage all the messages, all the questions. Plus, if in case anyone wasn't able to attend, then they're also able to see it here. Okay, more questions, and then we're going to wrap it up in the next 2 minutes, because it's already 10 p.m. for all the Indian people, and I want to be respectful to all the people in India and the other regions as well. So any more questions in the next 2 minutes, and then we wrap this up. Yes, you can. Swami, this question is for you. Yes, you can deploy it in simulation. Thank you so much, Mr. Rocks. Means a lot, and we are here to give you support. So we're just doing our work. Don't worry. Okay, so we're gonna end it here. It was a great session. Thank you so much, everyone, for all your questions. I hope it was helpful because I was getting so many requests as to do more of these workshops so that you can become comfortable with the platform, which was exactly our intent. We also didn't want to make it very long because I understand that even though these are short, but this helps you get more context. So the next follow up of the session can be you asking us more questions around the workshop, of course, but also we are planning more such workshops, right? So like for example, we did one in simulation. Now the next time we want to do something with the remote lab so that every community builder can understand what can we do there. So if you have any such particular interests or references, please share it with us. We would be happy to take that in. Okay, still swags in SO101 not received. Swami, can you get back to me with your full name so that I can check with the team? Because from our thing, only 2 to 3 builders are left. All the other builders have received the hardware, and some builders are also receiving the swag as well. Can we get a session on UGV as well? Of course, the next one, let's plan it for the UGV. I don't think I can invite. Okay, I don't think I'm able to invite Vittorio up here for speaking. Can I buy SO101 from Cyberwave? Yes, absolutely you can. We are actually releasing a fun offering, and it's already there out there for some builders. But if you want to buy or rent SO101 from us, we are running a special offer for all the builders and for all the early people. So actually you can DM me and I can take you from there. I'm just also going to take a screenshot of your username so that I can get back to you after this with more details. Can we get the implementation docs for this project? I think I already shared them, but I'm going to share it once again. So this is the tutorial video, documentation, GitHub repository, everything is there in this particular tutorial. Yes, absolutely. You can see the Claude prompt and stuff in planner.py. So I showed it in the recording as well. So if you go back to the YouTube link after this, you can see the prompt and how do we call Claude and stuff. Yes. So a lot of people are saying DM. I'm gonna respond to all the DMs after this. Sorry, but there are so many DMs that sometimes they get. I'm not able to reply to all of these. But yes, any tutorial for the get my swag Khushi, you will get it. Kosi, it's just that again same problem, multiple geographies. It takes time. That's it. Any tutorial for the UGV Beast? Actually, if you go here, you can find a lot of tutorials for UGV Beast SO101. So just go to our documentation, you can find them. I've also sent a link here. Okay, everyone, I'm going to wrap it up here. Sounds good, Q. I'm just gonna get back to you on this one. Let's wrap it up for today, and thank you so much for joining, and I'm gonna get back to you with all your questions on DM. If you took any screenshots or if you try to make something from this workshop, do tag me and Cyberwave on Discord and also on our socials so that we can repost it with our network and help you find a better opportunity somewhere else. Thank you so much, and I'm gonna see you again soon. Bye everyone.